So let's see how you did. Once again, you flip these two numbers, so instead of 7557, 1 just flips to itself. -2 4, 6 -5, 3 -9, and 0 2. When it comes to graphs down here, there's two different things you can do. What I'm going to show you first is basically just kind of off of what we just did. Instead of it giving you a table, you can just use the points to make a table. So you just kind of get all the points that you can, and you write them down. So this one is 2 5. This one is 1 3. And 0 1. -1 -1. -2 -3. And finally, it looks like -3 -5. If you were to do the inverse, then these two columns would shift. So this would be 5 2, 3 1, 1 0, -1 -1, -3 -2, and -5 -3. And if you plot these points, you get that one, 3 1, 1 0, -1 -1, -3 -2, and -5 -3, like that. And since the other one was a line, this one's also going to be a line, so you get something like that. And it's actually really cool, as we're going to do on the back. It turns out inverses are always going to reflect across this line right here. And what I mean by reflect is, if you were to have an XY coordinate plane like this, and you were to make a graph, let's just say it's something like this. If we had this graph, and I was to reflect it across the x equals y line, which is basically just the big diagonal. I'm just going to fold it in half. You can kind of see it through the paper here like that. I'm just taking this, putting it over there, and if I was to trace through this like so, then when you flip it back up, ta-da, that is the inverse. That's what it's going to look like. It's across this right there. And that's just what it's always going to look like. It's the opposite, meaning when it's flipped across that. So onto the back of the notes. There's two ways to do it. All inverses reflect across that line, like I said, so you can either graph visually using that fact. Like if I just kind of wanted to eyeball this one, then I could say, well, here's my original, and this would go here, across that, and if I was just kind of turn it sideways, like that, then you can kind of see, like, right here, it's going to go away from the line. Here it kind of comes towards it a bit, and then it goes out like that. So it's like reflecting across that line. So my answer should look something like that. It's just an approximation, but it's going to look something like that. If you want to use the ordered pairs, then looks like this is 0 3. So instead of 0 3, 3 0. Instead of 1 4, 4 1. Instead of -1 3, 3 -1. I think I shifted those over. And it's going to look like that. Once again, just kind of reflecting across that. As you can see, it does have the points there, but it is going to look somewhat close to what I had before. Right? It's the same shape. I just had it in the wrong location because I didn't have the exact points. Over here, same thing. This is 3, 0. You could just do 0, 3. 2, 1 is now 1, 2. 4, 1. 4, 1 can be 1, 4. And I don't know if there's any more. Let's see. 5, 4. I guess 5, 4. So you can make that into 4, 5. 1, 2, 3, 4, 5. And I guess we'll do 1, 4. So 4, 1. Boom. And it's supposed to reflect across this. It's going to look something like that. A lot of times people have trouble like actually connecting the dots after we do them. You can always double check afterwards to make sure it looks like it reflected across that line. Another way to think about it is like if you did 3, 1, then from 3, 1, it's supposed to go towards 2 other points. From 3, 1, it goes to other 2 points. So from the 1, 3 point right here, it should go towards 2 other points. It should go towards the other 2 points because it has to be the same shape. Go ahead and try those two. Press the pause button and give it a shot. Okay. Here, I'm just going to go ahead and kind of show you the answer. So, 0, -2, -2, 0. It looks like 4, -1, so -1, 4. And you get these points right here. So the line looks like that. And on this one, it looks like there's kind of a vertical thing going on at 2, 2, 0. So at 0, 2, well, what's the opposite of vertical? The opposite of vertical is horizontal. This is going to go horizontal after everything. So like if I went 2, -4, I could go -4, 2. This whole thing is going to be pretty much horizontal going that way. This part, you know, if I try to show a reflection, in order to kind of reflect, it's going to have to go that way. So I can kind of tell it's going to go like that. Otherwise, you can just choose the different points again. It looks like it goes through 6, 7. So at 7, 6 it would be there. And at 3, 5. So 5, 3. So with these points, you can kind of show it going through them like that. And that's it. That's inverses. That's graphing, making sure it reflects. I strongly recommend always doing the inverse on the original graph because chances are you'll eventually get some kind of multiple choice question and, you know, you'll have your graph all the way up here, but then all your choices are over here. And it's like one of them will look like this, one of them will look like that. One of them will look like this, etc. And it's hard to match this to that when it's all the way over there. But if you were to kind of do it over here, whether it's by flipping points or through drawing the inverse, it's like, oh, okay, well, definitely my answer is supposed to look like that. So then you can just say, well, my arrow is pointing up or left. This is not going left. This is also not pointing in the right direction. It's supposed to look like that, and it would be that. So it is very, very beneficial to do it on the same graph and then kind of match it over if you have to do that kind of thing. Well, at least that's my 2 cents. And that's it for inverses. Yay!